So now that we have the tractor itself up to the task of handling the stresses imposed by a loader, let's talk about putting a loader on the tractor. Everybody's seen a loader before, and there needs to be a vertical tower somewhere in this vicinity with a hinge point somewhere around here, and the arms will stick out front and pick everything up. That vertical tower has to sit on something. So having a look here, it becomes pretty clear we don't want to try to get underneath this shaft. If we get in front of the shaft, then we're interfering with the lift. So we'd have to get all the way up into here. And all the way up into here, we're almost up into the front wheel area. So we're clearly going to have to go behind this shaft. So that means that our loader posts are going to have to stand in this vicinity. So I'm thinking that we will put the foot of our loader post right here and tilt it a little bit forward. And by tilting it forward, that will give room for ingress and egress for the operator. So I need a support platform right here that's strong enough to hold up a loader. So if we look down under here, we do have 1.5 inches of space until we hit that black plastic shield. But the good news is the shield is lower than it needs to be. So we can eliminate that channel and we can go all the way up to the frame. And then if we had a steel member that was about 2 inches thick, it could bolt right up to the frame, stick right here, and be our platform to hold the posts that are attached to the loader arms. So let's talk about the cross member. It needs to be wide enough to hold the base of the towers, and it needs to have a very narrow profile so that it can fit between the bottom of the frame and on top of the mower deck. This is the same stuff that we made the front axle out of. It's the same raw material that the loader arms will be made out of. This time we're just putting it in the configuration of this box beam. I'm having to do a couple special things to get this turned into a box beam. So in its full configuration, the height of the rail here, this point, hits in that corner so far that, that gap is too wide even to have a weld bead. So what I've done is I've gone all the way down the edge of this point and this point, and I've radiused the edge over and shortened it up so that it can nestle into that corner. And now notice that the top gap is narrow enough that, that a weld bead could fill this gap right here. So it'll take a couple passes, but that gap can be filled with bead, locking these beams together. One on the top, and flip it over and do this one. But in order to get the full strength out of these vertical members, they have to not be allowed to twist. They have to be kept in a clean vertical plane. So to achieve that purpose, I've drilled holes in here every 4 inches. This is a 9/16 hole. And these holes will be filled with weld bead. So this flange will be locked to this one all down its length, under here with a continuous bead, and up here every 4 inches. Now you may also have noticed that I have these 1/2 inch plates put in here. And these are the points that penetrations are going to be going through. This is the top piece. Holes will be drilled in this. And when it's installed on the tractor, 2 bolts will come up through here to engage in a frame rail. 2 bolts will come up here to engage in a frame rail. And 4 bolts will come up here to engage in the loader support post. So, there again, this is only 1/4 inch thickness across here. The point load of the bolt right here on this 1/4 inch plate, I felt like was potentially going to dimple it and, not really give a good enough strength. So by adding this nice beefy reinforcement plate, the load at the point of that bolt head, is spread out. Next, I'm going to go ahead and drill. I'm going to measure where I want the holes to be, drill them in this piece at 1/4 inch. And then I will hold this piece up under the tractor and then drill through the frame with 1/4 inch. By the way, we're going to be using 5/8 bolts for this. A 5/8 grade 1 bolt is good for 9,300 pounds. I think that'll be plenty strong enough. So by beginning with a 1/4 inch bit, which is a much more manageable job, I can get the holes, in their proper location and then just follow that pilot hole with a 5/8 bit. And I'm also going to have to decide where to put the holes here, and I kind of need to do this before I weld this thing together. Here we have some progress on the beam. I've just finished carefully laying out and drilling these holes that will be used as a pilot. I have located these holes by measuring from frame rail to frame rail, and then measuring how much of that rail I have room for a nut to sit on top of, and then centering this hole in that space. So you will, insert that bolt up through that hole. I've confirmed that my hole is big enough for the socket that will tighten it down. All you need is a lock washer on here. And like I say, each of these bolts is good for 9,000 whatever pounds. 9,000 is more than adequate. Before I weld these two halves into a single member, I'll go ahead and position this where it's going to be and drill those locating holes in the frame of the tractor. And then I can drill these holes out on the drill press. I'll drill the holes in the tractor, upward, using a little trick I'll show you. And then we'll be ready to attach this together and then attach this to the tractor. Hello and welcome to Down Under the Tractor. I'm trying to make the decision. We're looking at mounting this cross member. And I'm trying to make one of the final design decisions that I have vacillated back and forth the whole time. Right where I'm mounting the cross member, the frame has been notched out to receive this lifting shaft. And of course, my piece of reinforcement is also notched out, which is to say that that's the weakest point of the middle of this frame. And hanging all this weight off of the very weakest point bothers me a little bit. So what I've thought about doing, just to add some limited strength, is sandwiching this 1/2 by 2 inch steel. Put this up here first and bridge this gap and tie it here back to there, with a bolt right here. So this 1/2 inch steel would at least provide a box. It would provide a, if you will, a bowstring across the bottom of the cutout. And then this would just go up tight to the 1/2 inch steel. Now the trade-off is the vertical space, because we have to fit a mower deck under here. And in an area where your clearance is planned to be less than 1 inch, dropping this cross member by a 1/2 inch is not a decision I make lightly. So I'm laying under here. It's either time to drill these holes up through the frame and move on without the 1/2 inch plate, or it's time to add the 1/2 inch plate. And we are going to add the 1/2 inch plate. If I break the frame, I can always come back later and add the 1/2 inch plate and try to do a bunch of repairs. Or I can do it now and get it over with. The deck will still be perfectly usable. It just won't come off the ground quite as high as its factory cousins. And I guess I'm okay with that. So I should have filmed it, but I just finished bending this steel in the electrified shop press. This is the valley that jumps across where the lift shaft protrudes downward. The electric motor is not strong enough to straight up bend the steel. But when you start using the hand pump, around the time the gauge reads, 5,000, the steel starts to yield. So the first thing we did is we bent the whole thing this way, and then we came back and put this bend to bring it back this way, and then finally we did this bend to flatten this tab out. And then a lot of adjusting, and that's where the electric motor comes in, because I've probably done 15 different setups where I bring the head down and just do a little adjusting. So the electric motor just saves an incredible amount of time. So with the two pieces clamped in, I will drill through these with 5/8, and then we'll bolt these in place, and then we'll carry on where we were. Alright, so let's talk for a second about drilling these 5/8 holes up into this steel. Any of you who've ever tried to drill a little bit larger diameter hole like this in something that's awkward and inaccessible know the terror that I feel when I consider that I need to drill 6 of these holes. I have to lay on my back, the steel chips are going to go right in my eyes. But worst of all, I'm going to really struggle to develop enough pressure to push this bit in. The bit will bite the steel and pull the curls down and out of the hole, but I have to provide enough pressure to get it to bite. Otherwise it just wants to sit there and burn. The reason a drill press can go down through here so easily is because you pull the handle and it applies pressure to that bit. And so we can, using our own trick, provide pressure. All we have to do is get the bit in place, get it completely vertical, and then, slip this jack under it. And by turning the handle of the jack, we can bring the jack up and it will push this thing right on through. Voila! Took a minute, but it didn't take any effort. So I want to show you how this crossmember is going to bolt onto the frame of the tractor. So if you imagine that this is the frame rail of the tractor, and this is the outside part that we can see, and this is the hanging under lip. I welded up this carrier that has these 5/8 nuts welded on it, and then this 1/4 inch nut welded in the center. So the frame rail, you saw me drill in the frame rail for these holes. So this carrier will be held in place with a socket head cap screw, and the socket head of the screw will be left hanging down, and the head of the screw will act as a locating pin. So I'll have a corresponding hole in the frame rail. So all you have to do is slide it around until the hole sets on the 2 cap screws, one coming out of each rail, and then your bolts will screw up through the hole. I just got the first side done. I'll put this in place, and then I'll create another one just like it for the other side. Here is the cross member bolted on for the first time. Now the key is that this cross member needs to be removable, because there is stuff up inside that frame that you sometimes just have to get to. I intend to make the thing a quick detaching loader where the majority of the loader can come off in just a couple minutes, and leave this behind, as well as the stand, the vertical post that comes up out of it. But there will be times that you just have to take it off and get up in there. And if it is an hours-long struggle to get it off or to get it back on, then it's going to make you want to just avoid it altogether. So I'm trying to make it fairly straightforward. It is heavy, it is awkward, but with a jack stand on one side and a jack on the other, hold it in place and start the 4 bolts and tighten them up. So I'm hoping that that's a workable solution long term. Alright, little progress update here. We have completely finished welding this cross member, filled the bead on both sides. Had to go back places like this where it's going to bolt to that flat flange under the tractor. This has to be perfectly smooth, so I flap disked it there. And then here where this plate is going to bolt down tighter. Then I'm running out of 1/2 inch plate, so I took this 1/2 inch bar and cut it to 5 inch lengths, and then welded them in the center to make a functional single plate that's 5 by 6. And then the next thing is to cut the C-channel to build the 6 inch by 4 inch U shackles, stanchions, standards, whatever you call them, the piece that's going to stay on the tractor all the time that will receive the arm of the loader. Well, here I'm getting my first look at how it's going to be. Of course, this whole front face will be cut off right here. This will just be sawed off straight across, which will leave this as a U-shaped shackle. So anyway, I'm getting my first look at how ingress and egress on the tractor is going to be. And that has been one of my concerns, is I don't want to lock the tractor up so bad that you have to kill yourself to get on and off. And I really think this is going to work. By angling it forward, there's just about enough room to put a foot right there. Put your right foot right there on that pad, and then swing your left leg kind of up over and out of the way. So it looks to me like this is going to be a workable solution. Okay, with the cross member finished and this bolt-on plate finished, next thing is to build from this point up to this upper fulcrum pin that will sit in this vicinity here. The location of the pin, it's dependent on where the front arms go and that they be able to reach the ground and not strike the front 2 wheels. So I need to hit this spot very, very close to where it's at on the drawing. So to do that, it's kind of a slow, somewhat frustrating process of building upward. First of all, I created these I had just a little bit of 1-inch plate, and I drilled a 1-inch hole and cut this groove. So that is where the detachable arm will engage in that groove. And from there, these will be installed in this U shape to hold the actual detachable arms. So this will get the pin drilled and welded here, and then on this end there will be a pin boss here. Alright, so I just finished welding this. I welded the two halves together first, intentionally welded them in a little bit open configuration, and then put them in the bench vise and squeezed them back till they were parallel. But I wanted it to be in its final cool and happy condition before I welded it to here. I didn't want to weld it to here spring loaded and then have this kind of pop open. On these sides it's fairly straightforward. Here up in this meaty part of this corner, there again it's about that thick in the corner. So I V'd it way down in and then filled that whole groove with weld, because this is such a key point of tension, right? As the bucket tries to go down, it tries to break this off, and there's a lot of tension right here. Inside here, I went ahead and ran a little weld bead on this bracket here. It doesn't need a lot. It's being held down by a bolt tension. It's just holding vertical weight. And you can see I welded in the nuts so that those will hold still. Alright, so having gotten both of the base receiver assemblies completed, I then have gone ahead and fabricated both of these vertical members. They're notched out to fit over the hook down here. They're drilled to receive that pin. And then they are internally reinforced with 1/4-inch plate. And then up here at the top, they're externally reinforced with 1/4-inch plate. And plate that I chose to leave a little bit of this thick web on. We kind of doubly reinforced it out here, give it some strength. So then with both pieces clamped into place on the tractor, I have just measured up 36 inches from the floor and then marked, and I'll drill there. Now the reason I didn't just mark them individually, like measure from here or whatever, is because I want to make sure that even if the cross member is not completely level, even if the length of this is not quite right, even if the height of the pin and the offset of the pin down there, by just measuring from the floor with it in its final position, it gets it just right. So next I will hole saw these for 2 3/8 inches. And then these pieces, this is the end of what will be the loader arm, and that piece is going to ride right in here. And then there will be a pin boss welded into here to mate up to this. So what I will do is get these holes drilled, get these pieces clamped back in, and then we'll run a bar through this pin boss all the way across to get everything perfectly level and perfectly in place, and then we'll weld these flanges in. Well, if I'm going to tell you all the proud victories, I guess I might as well share the screw-ups too. So, you just heard me talking about measuring up from the floor to choose the center of the hole. So I scribed the center of that hole, and I drilled it out with the hole saw. Everything is great. However, I didn't have that piece fully seated in the socket. When I put it in and put it in the hook, the back flange of the piece was resting on those top of those bolt heads back there. So as I tilted the piece up, it raised up, and the rod came up out of the hook. So it was artificially high. So when I measured from the floor and scribed on it, we'll come to find out it was sitting artificially high. So now that hole is 3/8 lower than it really needs to be. Well, you say, no big deal. I mean, the exact pivot point of the top of this loader is not critical. And you're right, with one small exception, and that is that this rod was going to lay in this pocket, nice and diabolically planned, to line these two up. Lift the hood up, lay that rod right in that pocket, line them up. But I think you can tell the problem. That by dropping it 3/8 of an inch too low, I have now made it impossible for this straight rod to run from hole to hole. So now I'm going to have to manufacture an articulated rod, which is to say one that has a U-shaped, hoop to it that can get around this obstruction and still be straight as an arrow. And that is going, it's not impossible. I've already figured out I'll use a piece of flat bar and I'll weld this rod to it and blah, blah, blah. But none of it had to happen. If only I had realized that that piece was not sitting down in the socket where it belongs. I'm glad I at least realized it now before I built everything. And then come to find out, hidey-ho, I don't have that piece where it belongs. Put the piece down where it belongs, and now the whole loader is, 3/8 of an inch cockeyed. So I at least caught it early in the game, but if I'd have caught it 10 minutes earlier, I could have saved myself an hour's work. So when it comes to building this shaft with the offset, there are two challenges. One is getting the pins perfectly in line with each other, and then the second one is of holding them there. So I'm using this extruded aluminum channel. It has this nice straight groove in it, but the groove is too wide for the pin, so I've cut in half a precision pin and lay it in there as a spacer. So now each of these 3/4 pins are snug into this channel, and by being snug in this channel, that makes them in line with one another. Now all I have to do is weld this to them. Now the only trick here is considering the warpage. When I hit this with the welder, it's going to draw up a certain direction. So what I'm going to do is just do a very small tack here and then here, and the draw up really should just be a curling. It should just curl this piece this way a little bit as it closes that gap, and then I can just lay it face down and do another spot on the other side in the same location, and all that will serve to do is draw these pins tight to the face that's up against them. And there it is, just a decent weld this side and that side, trying to stay in the center, because the farther you get out from the center, the more the heating and cooling is going to tend to twist the rod. And I have held it up and looked down it, and as far as I can tell, it is ramrod straight. So we will carry on with getting our pin bosses aligned and welded into place. Now let's talk about these pin bosses. This is the housing that will be welded to the loader arm. One upper and one down at the lower end where it attaches to the bucket. So my initial plan was merely to drill these out to 1 inch, stick a 1 inch pin in it, and move on. But the more I thought about it, the more I realized that once I have put this thing together and this hole starts wearing out, it's going to be really difficult to bore it out and prepare it. So I decided to go ahead and do it right on the way in. And it doesn't help that I have all you guys looking over my shoulder and judging everything I do. Thank you very much. Well, I decided to go ahead and bore these out for a bronze sleeve. I went to the Oil Light catalog and simply looked up the sizes of what they sell and what's available. Part number 121724. Googled that part number. It turns out there's a guy on eBay that had a bunch of them for $7 a piece with free shipping. So I picked up 4 of these, and looking in my machinery's handbook, I see that I'm supposed to give it 1 to 2 thousandths of a press fit, which is to say this is 1.065, this is 1.063.5. I also ordered some 3/4 inch water hardening rod, and the reason is it's already polished and perfectly on dimension. Because this is not oil impregnated, I can freely press it in advance and then weld it without worrying about heat distortion and all that. The last thing I need to do before final assembly is drill all the way through for a greased fitting here, and then I will take a carbide bit in a Dremel and make a ring inside so that the grease can get all the way around the shaft, and then do a couple little furrows coming out from the center so that as the grease is forced in, it will travel along the shaft as well. So just a quick aside at this point, it's time to mow the lawn again. So I mounted up the deck with the new cross member and standards in place, and just finished mowing, and I'm happy to report that I didn't find any issues with the use of the mower deck and the cross member and that install. Deck still goes up to plenty high of a height, and I don't see any long-term issues with it. I think it's going to work like a charm. Now, in preparation for welding these bosses in here, you know, this plate has been welded all the way around the perimeter, but it's not joined here right at the interface where this boss is going to connect to it. So I have very deep V-grooved down in here to where you can just make out that I have penetrated into the substrate plate. And the idea there is the center boss is pretty much the full width of this distance through here. So I cannot weld to here from the inside. It's not going to be sticking up in the inside in a way that I can weld to it. So because of that, I have to do all the welding from the outside. So I have V'd down in here deep enough that my bead penetration from the outside will get all the way down into both layers of plate. Takes some work, you know, with the angle grinder. You know, I've had to stand here and work at it for probably, I don't know, 12 or 14 minutes just on this one tower, and I'll have to turn around and do the other tower the same way. But the end result will be a good penetration weld that will never have a problem. Okay, so with the holes in these posts drilled and beveled out, I now have everything carefully clamped into position. What we're being sure is that the rod ends are level with the floor, that they are plumb, that they're not leaning in or leaning out, and that the distance from the rod end to the rear axle is the same on both sides. And that makes sure that the bucket will not be turned left or right relative to the tractor. So we now have it in the exact position we want it. We'll tack weld these, and then we will drill through with a 1/4 inch bit what will be the pilot hole for the hole saw. And that way the pin that causes this thing to center up and locate is in place at the same time that everything else is in place. Because later on the hole saw will just follow that pilot hole, you know, placing that housing exactly in the right place. Alright, so now that we have the rear support towers finished, we know the exact width across the loader arms. And I think before I build the actual loader arms, it would make the most sense. We have the upper end of the arms finished. I'm going to go ahead and build the fitting that the lower arms will join into. In order to do that, I have to address the quick attach concept. So I've decided to build this using a quick attach bucket, primarily because I have a set of forks that I think will also be very handy. But you know, it just gives it a lot more flexibility down the road. Having done a lot of research on quick attach, I like the deer concept the best, where it has the hooks at the top of the bucket. But those are very expensive to buy and very complicated to try to build. Secondly, the Bobcat quick attach seems to be pretty much the industry standard. But there again, they're very expensive to purchase. Even the pieces with which to build an adapter is over $100 just to get the actual, fittings, if you will. And then from there, it's taller and bigger and heavier than is appropriate for this tractor. So what I settled on is this. This is a quick attach system from a Toro Dingo. And it works in a similar way to the Bobcat quick attach, in that a piece with a 45-degree lip just hooks into it. And then you secure this bottom flange with a pin here. And when you drop the pin in, it can't come out down here, and it is locked in place. I got this part shipped to me for $50 all inclusive. Honestly, I'm surprised the shipping wasn't $50 for this part, to say nothing of manufacturing it. So this is the direction that I'm going to go. Having said that, this is really not wide enough for my purposes. It makes a lot more sense to have the loader arms inside these two flanges, rather than trying to build these hooks with the arms out here and you have to build some kind of structure to cross the gap. Makes a lot more sense to me to just put the loader arms inside. Now, our loader arms are right around 30 inches apart. This is 20 inside here. So I'll run this through the bandsaw, split it in half, add in a 10-inch filler piece. It doesn't really have to be a high-strength filler piece, because this is going to be permanently welded to the bucket. So the bucket itself will provide some of the structure and the stability of this piece. So having made that decision and having gotten the piece shipped to me where I could really measure it, I did some careful drawing. This is the lower bucket pin, you know, the pivot pin that the bucket will tip forward on. This is where the hydraulic cylinder will attach. I really had to kind of play with it to get it just right, to where it could engage the bucket, it can tilt back about 7.5 degrees, and then when it's fully raised, it can tilt all the way forward enough to dump. It's not really rocket science, but there's really only one setting that will work. So I had to play with it until I got a geometry that would fulfill both the rollback, the normal operation, and then the dump operation. Now the ideal steel, I think, to make this out of would be about 3/8 inch plate. However, I don't have that kind of 3/8 plate. I have some 1/4 inch plate, and I have this 1/2 inch plate that a good friend of mine gave me. So although it is overkill, I'll be building these hook flanges out of 1/2 inch plate. So from the drawing, I have just made this template, which in particular has these holes very carefully located. And so then I just found a configuration where the template can lay on the steel without encountering any of the holes that are problematic. Center punched the location of the holes, and then just scribed the outline of the piece. And so what I will do now is run this through the bandsaw. Unfortunately, this 1/2 inch is just a little bit more than the electric skill saw is designed to do. So the bandsaw, I know from past experience, can totally cut it. It will just take me some time. I will lop off this end first, lop off that end, and then I have these smaller, more manageable pieces to work with. Having cut the relevant portions to the right profile, there'll be a big hole here, a big arc here where it welds to the pin boss, and then a slot here where it engages into the lip of the adapter. I put these on the sander and sanded them, got, you know, more or less a flat plane across here, and then put it on the other edge of the sander and got a nice clean 90-degree angle here, and then aligned these corners, clamped them together, and then I put a little weld bead on this corner and back here. Both these are going to be cut off. This will be cut off by the hole sawing operation, and this will be ground off because this whole back edge will be radiused. But meanwhile, it's holding these together. I want these holes, these various things that I do to it, the slot that I cut, the holes that I drill, I want them to all be exactly the same. So we'll do them all at once. And that way, once I cut these welds, it will produce 4 substantially identical pieces, and then all I have to do is get them aligned when I assemble them. We drilled this cul-de-sac hole, we drilled this 2 1/4 hole, we drilled this 2 1/4, what turned out to be a arced notch, and then just pulled it off the bandsaw where we sliced down to meet this cul-de-sac hole, and I gave it just a little dressing with the flap disc to put a radius onto here. And having done that, it chunks into place. And here are the 4 pieces ready to go forward. To begin building the bucket adapter, first thing is we have to build each individual unit that will be at the bottom of each loader arm. So this is the first one, and first thing I've done is I have, according to my drawing, I've cut a piece of this 6-inch C-channel to a 1/16 of an inch thicker than the boss will be. The idea there is that we want the boss to stick out a little bit inside. You know, we're shooting for more or less flush, but when in doubt, fudge a little bit of extra space. And I cut it very carefully square in all 3 planes, so that when I lay it down and bring these plates up tight, they should sit square both vertically and parallel. So all I have to do is clamp these together with the rod through. I am assuming that if I have these both flat to this surface and this rod coming through here, that these will line up acceptably. So, this one I have just done. I am happy with it. I'll get this one clamped up, get this welded up, and then we'll move on to the next step. So next we need to get all these bosses welded into these plates in a fashion that is in alignment. So what I've done is I've taken these welded up units, put them into this quick attach adapter, and then driven a wooden wedge in to run it up tight into its final installed position. So that makes these two units aligned in the same plane and at the same height. Then this rod keeps all of these bosses aligned. Now these are not being welded in. This is the boss at the end of the loader arm. This is just here to keep the spacing between these two bosses. One is narrow, the other one's thick. The thick one will be to the outside and will be drilled for a roll pin or a set screw, or I haven't decided yet. And then up here, these upper bosses, I have carefully spaced it so that they are equally aligned left, right on the plate, and that there is precisely 2 1/4 inches between these faces. Because this is where the T on the hydraulic cylinder will ride. It's 2 1/4 inches wide. So that spacing is important to be just right. And I will go through and tack each of these. These I will tack here, front and rear. And that way the weld shrink merely pulls the piece straight down. It doesn't try to cock it left or right. It just sucks it into this U-joint. And then I'll go through and tack all of these pieces, and then we'll carry it outside and do the full weld. I just used this Harbor Freight pipe bender. Put a couple bends in this 1-inch steel bar. It's not necessarily intended for solid steel bar, but being that it's only 1 inch, the 12 tons didn't even struggle. Now the point of the bar is to go here. The bar will join these removable loader towers to keep them in their proper spacing and orientation. It will help with side-to-side rigidity because it's locked at the bottom and it'll be locked at the top. But more to the point, when the loader is detached from the tractor, it will give this back end some kind of an official spacing support. This piece will come off with the loader, obviously enough, when it's detached. So it has to be something that can slip into place without hitting the hood, without hitting things, which is why the bend, by the way. Because it needs a little bit of a height up above the hood to get clearance over the hood to be able to slide, lock up into place. So now I'll work on getting some brackets to weld these two and then get this thing all attached in place. And here we have the cross brace completed and bolted on. I drilled and tapped this end of this fitting and bolted it in place, and then set the cross brace in place, clamped it here, and then, just tack welded it sitting here inside the building. And then unbolted it, carried it outside, and just fully welded it up. Came back in, bolted these two back in place, and then drilled and tapped in place using this hole as my actual, guide for both drilling and tapping. So, it is bolted in place and done. By the way, I've given a lot of thought to clearance here. That seems like that's going to clear there okay. And then I'm fairly confident that it's up high enough with the hood closed that I'll be able to rock this thing forward, and I don't think that will strike the hood until I've gone, really pretty far. So I want to probably rock it forward 1.5 inches or so, and then come up with it. So I'll go ahead and take this thing apart and get this piece out, and then I can use this to align my bushings when I make my bucket adapter. And there it is, one completed bucket adapter. So all we need now is some loader arms to connect this pin to the pin that will go up there. Later on, I will fill this pocket with a solid piece so that this triangle is, engaging as a solid piece. Fill there and fill there. But there's really no hurry on that. I can go ahead and get the loader built and operating and then kind of do that as a cleanup project. Besides, once I can raise this thing up in the air, it'll be a lot easier to get to and work on. So I want to take a minute to talk about the triangular brace that runs from this bar up to the standard. It was always part of the design to, remember we talked about using this steel bar to join this heavy steering bracket to the outer frame, and then extending this bar out here to, travel in a triangular member up to the top of the loader arm, which makes the loader arm in a triangle, and so it cannot tip forward unless this member, crumples. This keeps that forward tilting strength a lot more than just torque down against the bottom of the plate. So I have held out installing this steel bar just because once it's in place, it becomes pretty difficult to go back to change your mind. But enough time has gone by that I'm pretty confident that it's time to install the bar. So the first thing I did is I installed a piece of bar, jacked the tractor up so that the front end can rock and articulate, and turn the wheel all the way to the inside. What that accomplishes is telling me of exactly how long this bar can be before the tire will strike it. So this is the point of maximum upward travel and inward travel. And as you can see, I set the length of the bar just shy of that. Then I had to make a decision on how to attach this triangle stiffening arm, how to attach it to the end of the bar. I could have drilled and tapped the bar and just put a steel plate over it and bolt it in, which wouldn't have been a terrible idea, but the bar then becomes a little weaker here because it's hollow where the bolt is going. And what I eventually settled on is just welding a collar here to give a big, heavy seat, and then threading the end of the bar so that we can just attach a steel plate. So it turns out this piece of 1/2-inch steel that I've just bent just a little bit of a curve in, we need a little curve to head out towards the standard, and then just threaded this so that can bolt on and crank down. Then the question is clearance for this steering knuckle. So if I do it as a truly straight shot from here to the top of that standard, I will in fact strike the steering knuckle. It's not quite clear. So what I've done is I have angled this, a little bit upward so that my 1-inch round bar actually sits in this path that's just a little bit articulated upward. That way we're clear of the tire, we're clear of the steering knuckle, and the bar itself is nice and straight. So I'm very pleased that this bar can just be a straight shot. I feel good about this joint here being good and strong. And then all I have to do now is attach the bar up here at the standard. Meanwhile, up here at the standard, we now have this bar coming in at this angle, and we need to join it into place. Now, I don't really care to join the bar directly along this face for a couple reasons. One, this steel's pretty thin, and I don't have room for a fastener head very much inside. So my connection from the bar to this steel is not going to be very substantial. But secondly, for the purposes of resisting force, and especially under, jerking loads and that kind of thing, if I attach to this plate and then the loader arms are pushed, very hard backward or pulled very hard forward, the tendency is going to be for this plate to hold still and for this U-shackle to bend around that spot. And once the U-shackle has bent or twisted even slightly, then getting that pin in and out is going to be pretty hard to do, and it begins to want to bend the entire loader frame kind of out of its proper alignment. So I don't want to just trust this little 1/4-inch plate as the sole connection to hold back this triangle brace. I actually want the steel bar itself to have an independent 90-degree strength so that the force of any loads pulled back and forth is actually transferred uniformly across this back plate. This back plate is in the proper plane to take fore and aft loads, and even if it moves and flexes, it's not going to be twisting if the turn between this bar and this bar is strong enough to resist the bending moment. So to that end, the join from this bar, represented by my finger, needs to have its own independently strong bend, and then it needs to join to this back plate. So what I've decided to do is to use a 3/4-inch plate bolted to this back face in 4 places. and then welded around the bar. Here we are. I've just finished drilling and tapping these 4 holes that this bolster plate can be bolted on here. The triangle rod will come up through here. This whole joint will be filled with weld. I will bolt this back on, and of course we'll line up the bar and weld here. And when I'm done, I'll soften these edges a little bit with the flap disc, because this is, ingress and egress passes right past here. And here we have the triangle brace completed, painted up. Coming up here, just a nice thick steel plate, and like I say, it'll keep the pressure that's applied here from twisting that shackle. Now, lastly, I will put some kind of a gusset on here, because that is more torque on this 1-inch rod than I had visualized, and I could totally see that bending. And there is the gusset that completes this crossbar. So just took some 5/16 plate, and I just cut these notches in it to go in between these fittings here, and then put it in place, beveled real hard at the top, and welded all across the top. So now, for this 1-inch bar to bend, it now has to stretch this gusset, which, is much, much more difficult to do, which of course means it's a lot stronger than it was a few minutes ago. So here we are working on the loader arms. Now the loader arms will be made out of the same 6-inch C-channel as just about everything else. The design is very similar to how Case manufactured the 646. It's a very similar arm profile and design. Now this was trickier than I had anticipated. Each one of these is made up of 4 unique pieces, which are then mirrored, so there are 8 unique pieces that have to be cut just right. So I went through and laid out, where each piece will be cut out of the channel. Now this view is looking down at the flat face of the channel, with the flanges of the channel hidden from view. So when you look at some of these, to place it on the drawing, you have to mentally pick it up and flip it over, and you can mentally confirm, yes, that piece looks like it will fit that location. Now, having said all that, if I cut these all out and find that one of them is exactly backwards, I won't be that surprised. I hope that's not the case, and if it is the case, then I will obviously have to compensate. But like I say, it's mentally trickier than I expected it to be. So I now have these stacked outside. I have each one labeled with what it is, and a few of them I actually have this, this upper angle laid out. As I'm cutting this in the bandsaw, I anticipate, for instance, if I start cutting here, as I start getting back here, feeding it this way, the piece is going to start getting pretty floppy, because there will be less and less of a connection holding these 2 big halves together. So what I will do is, once I had fed it in, give or take this far, I'll go ahead and put a C-clamp right across here. Kind of lock this kerf in place so that as I'm feeding through, it's not getting more and more loosey-goosey on me. Probably take me a couple hours to get these measured out, line struck off, and run through the saw. Alright, so there is the first one welded up. As per the plans, I just set this outer angle to 104.5 degrees. Lined it all up. Tack welded the reinforcing plate behind, clamped it together just like I did the axle, where I welded the reinforcing plate to one side, tacked it, and then clamped it to the other side. That gets these in the same plane. Adjust it until it's the correct angle, and weld away. Here I'm getting my first look at what the finished product is going to look like. I've just cut out the left lower inner, and so it corresponds to the outer, and will be welded here and then down here. And I'm very pleased with it. I think it looks the way I expect it to look, and I think it should be plenty strong and plenty capable. So I'll continue making the rest of these. I'll get each of the inner assemblies welded together just like the outer. I'll be using their corresponding outer to line them up. and then I will join the two halves. I've decided to put in this internal gusset here at this corner. I'm afraid that there could be some real twisting problems. I'm afraid the whole thing could kind of shear, as it were. There will be a gusset across here on the outside, but there's nothing to keep the box itself from warping. So by doing this, I turn this big empty box into a triangle and then greatly shrink the triangle that's for the upper and for the lower. I don't know if this is really necessary, but it's a easy and small step that I think will make the thing meaningfully stronger. It will be completely welded into this box that you can see, and then on the next box that drops down, I will mark where this is and drill a series of holes, in a straight line across here, and fill up those weld holes like I've done before that will tie this gusset to the other face as well. So here we are. This arm is completely welded up and ready for the next step. This arm is basically ready to go. This half of it's completed, beveled here and here, ground smooth across here. The other clamshell half has holes drilled here, and so clamp the thing together, weld the inner and outer perimeters. But before I assemble it, I went ahead and, from my drawing, drilled an 1/8 inch pilot hole at the center point of the pivot pin that will be here. The big boss will be welded in here. And then I overlaid this one, overlaid the left one on the right one, and drilled straight down through so that these now have the exact same pilot hole at the exact same place. As I've mentioned before, it's very important that these two pieces be the same. So we lay out and do the pilot hole for number 1 and then overlay that onto number 2, drill straight through, and that means that these two will have these center holes in the exact same location. With the arms welded up, it's now time to cut out this hole / notch that will be here at the end that the boss will weld into. So the idea is that this is going to kind of wrap around and be welded onto a 2 3/8 inch thick piece of steel that's going to act as the pin boss. I elected to just leave it a little bit long where I can just mark the center of where the notch ought to be, and then I'll use this hole saw to cut that notch out. Now, as you can tell here, I have a bit of a special hole saw, which is that normally this hole saw would have a 1/4 inch pilot bit, but I currently have this what turns out to be 31/64 piece of steel in here. And the reason is that we'll be cutting both the left and the right as it goes down through. We're not just cutting plate, we're actually kind of carving out a circular thing. So once it penetrates this top surface, it's going to want to move and walk. So this mandrel is long enough to begin being completely encased in both the top and bottom plates so that it will be located all the way on its journey all the way down through. So the only trick is, instead of a 1/4 inch pilot hole, we're going to have to use a 31/64 pilot hole. Now, I could have just used a 1/4 inch rod and a 1/4 inch hole would have done, but I feel like because I'm asking it to, withstand a lot of lateral pressures, a little bigger rod is a little better. So, put in this 31/64 bit, drill both plates through, chuck up the hole saw, and run it down through. Here we are, both of us, getting our first ever look at how the structure of the loader is going to look on the tractor. And I'm fairly pleased. What I need to do now is satisfy myself that I have these things pointing straight, that I don't have them off to the left or off to the right. I'll do some cross measuring corner to corner to get it square in this plane. And then I can do cross measuring corner to corner and get it square in this plane as well. that I have them perfectly vertical and that I have them perfectly parallel with the front of the tractor. Then I'll tack weld it between the arm and the pin boss. Then of course I will take it outdoors and weld it in real well. Just wanted to show you, the kind of methods you can use that are inexpensive and fast. I needed to keep these two arms, parallel and at a certain distance apart. So, cut this 2x4 perfectly square, and then drill this hole into here, and then that gives you a place to put a clamp on. And so it holds the thing simultaneously at the proper distance and simultaneously square. Then I drove in some little wooden wedges up there to keep those pieces centered on those shackles. And it is ready to tack weld. Now for each of these pin bosses, I've drilled and tapped for 1/4 28. And then on the inside of the bushing, I've taken a Dremel with a small round carbide bit and carved an interior grease channel all the way around, like, from the grease port all the way around the shaft, and then from the center outward in kind of a spiraling motion. So that way, when you pump this thing full of grease, the grease will completely surround the shaft and will squeeze its way from the center on out, so that the entire width of this bushing is covered with grease. That's the idea. And then a standard 1/4 28 grease nib screwed in here. Here we have the arms assembled to the bucket adapter for the first time. And I'm very pleased with it, but I think I'm going to probably have to change my plan. The farther I go, the heavier and more cumbersome the thing gets, and the more difficult it is to work on it, to make progress. So I think the next thing I'm going to do is go ahead and get the fittings welded up for these hydraulic cylinders on the side, the main lift cylinders, and then go ahead and disconnect everything and do the hydraulics next. Maybe I can analyze it now. Maybe I can flip this up and analyze now exactly where the cylinder needs to be mounted up here, and go ahead and get the cylinder mount done, the upper cylinder mount, and the triangle brace, which contains the lower cylinder mount. Maybe I could get all that done at once and just reassemble it one last time. So let's talk for a minute about mistakes and dealing with them as they occur. One of the assumptions that I made when I went through with this, I bought these cylinders, and before I bought the cylinders, they come with a little technical drawing. And in the technical drawing, it indicated that the width across here is 2 1/4 inches. Now that was handy for me, because based on the C channel that I have available to me to make this out of, this C channel is 2 inches across here, it's a 1/4 inch across there. So when you cut it and flip it, you get 2 1/4 inches right across here. That means that the thickness of this member will be right around 2 1/4 inches, and then the hydraulic cylinder will have the same width across here as the C channel is. We'll just put this plate across here, and then we'll slip the hydraulic cylinder up in between here and put a pin right through there. However, the width across here is not the same as the width at the other end of the cylinder. This is in fact 2 3/4 inches. As a consequence, this piece is almost 5/8 of an inch thicker than the arm of the loader is. So now I have to find a way to get this piece to fit up inside of here. And that is proving to be tricky. One of my first thoughts was to just take this plate and stick it in the 20-ton press and basically dimple it open. Press a crimp in this thing to open it up. The problem is this member is actually under compression across here, not tension. So if I open this thing up by introducing an intentional bend in it, I have given the metal a place to bend, so that when I put it under additional compression, the bend is just going to exaggerate. For compression in particular, it's important that a steel in a plane like this remain perfectly straight. So I cannot keep my strength and bend the thing open. So then you say, well, I'm just going to have to fur it out, to use a carpentry term. Put a spacer between here and here to bring this out to make it wide enough for that to fit in. So I'll have 3/8 thickening plates, and then I'll have this 1/4 inch bowstring plate out here. I need 8 20-inch pieces of this 3/8 bar. Then I still have to make the piece that comes up here. So I've added, 50, 60 pounds of weight. I've added a whole bunch of linear feet or inches of weld, and I've made the thing really ugly. So then I stopped and reevaluated, is that really my only choice? And the answer is not at all. In fact, what I have settled on is I'm going to go ahead and use these 3/8 thick bars in rows, stacking them beginning like something like here, and stacking row, 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 and then this will be the only reinforcing for the arms themselves. And I still get a pretty decent bowstring effect across here. So I feel actually better about the strength of this thing. Then I can take a single piece and put here with a hole to receive this pin boss and a hole to receive that pin boss. So the resulting effect is much neater, much easier to perform, and I think stronger. So this is the plan I'm going to go. I bring this up just because, I've been going off this drawing, confirming as I go that reality matches the drawing, which is based on my imagination. And whenever you're doing a process like this, there are inevitably situations where reality doesn't match the drawing, and you have to deal with it when it comes up. The final stage of modifications to make to the lifting arms before they get assembled is to drill out the 2.5 inch hole that's going to be the cross brace. It'll go right here at the front of the tractor, running across between the two loader arms, and it helps to keep them in parallel and keep them synchronized so that they're locked together. A hole this big is a whole lot easier to drill here on the mill. Its location is somewhat arbitrary. You can see I have a mark here where I kind of mocked up where I wanted it to be. I'm actually putting it a smidgen lower than I really wanted it to be because, hitting this cross plate. But lower is not really a big problem. It actually helps the hood to clear better if it's down lower. I can open the hood more with this down and out of the way. For true strength and stability, I think to a degree the higher the better. But, this is the best compromise. So this is where we'll put it. Fire in the hole. So here we have the 4 straps that'll be welded on the side of the loader arms. The upper hole will catch the bucket cylinder, and the lower hole will catch the lift arm cylinder. And anytime you're doing something like this where you need 4 identical pieces, it only makes sense to do the work in a gang fashion. So I clamped them together. I drilled all the holes at once, they're in the mill, and then I chamfered all these corners all at once, and then hit it with the flap disc to clean it up. And that way you get 4 nice, identical, kind of factory-made looking parts. And when it comes to placing and aligning the bosses for mounting the hydraulic cylinders, there are 2 things to consider. The first is that they need to be absolutely identical from side to side. Both of these lift cylinders need to be aligned with the exact angle of the lifting arm, so that wherever the arm is, both cylinders are applying the exact same pressure. If you get them out of a line, then what's going to happen is one cylinder is going to have to lift harder than the other, and it's going to tend to twist the lifting frame. So they have to be exactly the same. Secondly, you have to set them up such that the cylinders don't attempt to do something that's impossible. Now, what do I mean by that? Well, like in this case, this lift frame is currently fully on the floor. This is set to what I have defined as its lowest possible point. This is the point where the bucket is 1.5 inches below grade and is digging. So for this particular set of cylinders, the thing to do is to put the frame in this position, retract the cylinder 100%, and then attach the cylinder in place in this configuration. Now earlier, I set these bosses exactly the same distance, the same radius from the fulcrum pin, 27.5 from center to center. Then I brought it up until it came into range for being welded on of the distance specified on the drawing. The drawing specified 1.75 inches. So I made those adapters to exactly fill that gap, and then brought the thing up 14 inches between center and center and welded it in place. So the other side, in order to make sure that the other side is exactly the same as this one, I will simply start with this outer pin boss to be sure that it's the same measurement, 27.5, and then I will bring the other cylinder up in its fully retracted condition, bring the other cylinder up until it measures 14 inches from center to center. And at that point, however thick that bracket needs to be is how thick I'll make it. And that makes sure that this triangle that these three members form is exactly the same. If it's the same when it's retracted, then it will be the same when this arm of the triangle extends by 16 inches. So that is the approach. For this one, we do all our, our configuring with the cylinder fully retracted. For these front cylinders for the bucket, the case is just the opposite. In this case, we want the full extension of the cylinder to coincide with the point just where this bar would begin to try to go over center and then bend itself. You can imagine if I push this point down any farther, it's going to start curling under. And as it curls under, this bar is going to make contact right there and bend. Or at the very least, score it up. And this needs to be a very, clean, polished surface. So for this one, there is no danger to retracting it too far. If you try to retract it all the way, it just gets up here and kind of locks and just halts. But if you try to extend it too far, then you're going to tear it up. So for this one, we configure it with the cylinder fully extended. And by the way, the easy way to do that is I take my blowgun with a rubber tip, put it right here on the extensor port, and fill it with 120 psi. And it snaps out to its full extension. And then from there, simply choose the place where you're comfortable with this gap between the ram and this arm. I erred on the side of sloppy because, over time, as this thing starts to move and wiggle, I'm concerned that the bar is going to have some clatter and some movement, and I don't want it to rub there, even, as it gets some wear to it, and these bushings need to be replaced. So that was the point that I chose. So that's the approach to take, that you don't damage the cylinders and that you get the most travel and use out of the implements. So this morning, for the first time, I'm going to remove the loader at its detachment point because I need to burn in all of these pin bosses, completely around. This front cross brace needs to be completely welded up. Several more passes, and rather than do those all vertically, I'll just pull it off and lay it on one side and weld what's upward, and then flip it over and weld the other side. So I'll build a brace that has kind of sawhorse legs on either side and a cross member going across that will sit in the yard, and we can hook this bar, provide up pressure to disconnect, and it will just hold the thing in this format until I want to hook it up. So I need 2 A-frame legs with a fulcrum point about right here where my finger is, and then sawhorse style straight across that can lift up on this arm right here. And there it is, sprung free. Took me 3 or 4 minutes to do that. I just cut off a piece of unistrut that fits over the ram and acts as a lock to prevent this from retracting fully, just so it will stay a little bit off the ground while I need to drive it around. And so we've reached the end of this phase, the steel structure. I'm pleased with how it turned out. I think it looks decent. I think it'll be good and solid. The next step is to remove the loader from the tractor and remove the deck and the cross member so that I can get up under the tractor to work on the hydraulics. The final things yet to be done are to get the hydraulics completely hooked up, get that all working and operating as it should, and lastly, to actually fit the bucket to the loader. It seemed to me it would be a lot easier to make the final determinations on the angle and everything of how to attach to the bucket once the hydraulics are hooked up and operating. I hope you've enjoyed the journey so far. Not too far to go now. And as always, thanks for watching.